Okay, welcome everybody. Good morning. My name is Louise and I'll present a project that assessed the effect of sunlight exposure and depth on coral growth. This study was based on a restoration program that is implemented in the Maldives. So first I'll start by introducing the context and aims of this project. Then I'll talk you through the specific restoration program, how the data was acquired and processed. Then I'll present the main results of this study before discussing them and conclude. So first, let's talk about coral reefs. They are one of the main and biggest natural structures on Earth, and they have a tremendous ecological importance as they sustain 25% of the marine biodiversity. They provide food and habitat for thousands of other species. Also, around 500 million people depend on coral reef for resources, for tourism, but also for protection against erosion and extreme weather events, which is really important, especially in low-lying countries such as the Maldives. Coral reefs are formed by hard corals. They are colonies of polyps, jellyfish-like animals that live together and build a hard skeleton around them as they grow. The polyps live in symbiosis with zoos and thelly. Algae that are inside of their tissues, they provide them with shelter and substrate, and in return the algae provides the polyp with around 90% of its food intake through mainly the process of photosynthesis. But with the current context of climate change, coral reefs are threatened as they're highly sensitive to warming of temperatures. Worldwide, we are seeing bleaching events. That is the main response to the warming of those temperatures. What happens is that the polyps will expel their symbiont algae outside of their tissues. So if the stress remains for an extended period of time, they will eventually starve and die as they have lost their main food source. And since the zoos and thelly is the only color source of the polyp, then only the calcium carbonate skeleton remains and the colonies appear bleached. Bleaching events are a real threat to coral reefs. The last major event that happened and led to mass mortality worldwide was in 2016. In the Maldives, there was a decrease of 75% of the total coral cover, and around 90% of the colonies were estimated to be impacted on the island of Landa Giravaru, where this program is conducted. So in this context, there's a really high need for conservation measures. Restoration programs are implemented all around the world by various organizations. We can find different setup of land or in situ nurseries, and various methods are used such as ropes, boulders, or frames. However, often those organizations don't really have time to conduct quantitative analysis on their results, but assessing their performance is crucial to be able to increase the global efficiency. So this is what this program aimed to do, to test and quantify the effects of sunlight exposure and depth on coral growth, to be able in the long term to provide some guidelines for restoration programs. So the Reefscapers program started in 2005 in the Indian Ocean in the Maldives. First, coral fragments are collected on wild-growing colonies around the island by free or scuba diving. Then those fragments are grafted onto coral frames. They are dome-shaped structures made of metal coated with resin and sand. And those structures are placed back around the islands where they are monitored every 6 months to follow the growth by just taking pictures of the fragments. This map represents the study sites that were used for this study. So the sunlight exposure factor was assessed by comparing some sun condition to a shade condition. So all the frames were placed at the same shallow depth, but the sun frames are all the time exposed to full sunlight, whereas the shade frames are situated under the jetty of water villas, so they are never exposed directly to sunlight. The depth factor was assessed by comparing shallow versus deep conditions. So all the frames are exposed to sunlight in the same way, but the shallow frames are between 1 to 3 meters, while the deep frames are between 7 and 9 meters deep. In order to have the longest series possible for a robust assessment of growth, but also at the same time avoid bias due to the 2016 bleaching event, only frames placed in 2017 were selected. So considering all those criteria, 13 frames per condition were written for analysis. Photos were collected from the database, which lead to an average of 20 months of data per frame. The PhotoQuad software was used to conduct the photo analysis. All the frames used are identical to this one, so it enabled a consistent image calibration using the middle bar of the frame that is 30 centimeters long. Then polygons were drawn around the fragments and colonies to be able to extract the total coral cover in square centimeters. So doing that for all the frames and each pictures of the time series enabled the calculation of average monthly growth rates that you can see on the picture per frame and per condition. You see overlapping ranges, so t-tests were conducted for pairwise comparison of the conditions for the two factors. It shows that the shade and sun condition present statistically similar results, whereas the shallow and deep frames results highlighted a significant difference with the deep frames growing slower than the shallow ones. The sun and shallow conditions are not directly compared, but the similar results that you can see here are a good positive control of the analysis. Since those conditions were quite similar, the results are a good proof of the reproducibility and consistency of the analysis. The growth kinetic was also studied, represented as the total coral cover over time. So here for the sunlight exposure factor, we can see that we have quite different patterns. For the sun frames, they present all a quite linear increase ever since deployment time. But for the shade frames, we see that there's a really low increase of coral cover during the first 10 months of deployment, with only around 39% increase, compared to 147 increase for the sun frames during the same period. And it's only after this that the coral cover increases dramatically until it reaches levels that are comparable to the sun ones at the end of the total period. For the depth factor, both conditions present quite a linear increases over time. The main difference that can be noted is that the shallow frames presented quite homogeneous results, with all 13 frames presented really similar coral cover over time. Whereas here for the deep frames, we can see that there's more variability, with a few outlier frames that present a really low coral cover increase over time. What we can say about this first, about the sunlight exposure factor, is that the shade and sun conditions actually presented surprisingly similar results. The hypothesis was that the shade frames would present slower growth rates and smaller coral cover, since photosynthesis is the main source of energy for growth. But actually it didn't, so it seems that photosynthesis is not as impaired as it could have been expected. This is interesting for the exploitation of this condition for restoration program. And the delay in kinetic that was observed is most probably due to difference in combination of host and algae. This has been reviewed in the literature and shows that it can impact the overall efficiency of photosynthesis. So this growth afterwards could represent a good acclimation and a good potential also for restoration programs. For the depth factor, it's actually harder to conclude anything about this, as the two parameters seems to lead to discordant conclusion. The slower growth rates for deep frames would tend to suggest that deep is not such a good condition for coral growth. But at the same time, the majority of frames present overlapping ranges of coral cover with the shallow ones. So actually, this could suggest that it presents satisfying growth. So a solution to this limit would be to conduct the same study, but increasing the sample size to have a better understanding of the actual impacts of depth on coral growth. So some guidelines for future implementation of these programs can be drawn out of those results, with the shade, sun, and shallow conditions that should be preferred if the aim is the optimal growth efficiency. But the outcomes of this study, it can actually represent a really good basis for a longer term and several steps projects towards identifying bleaching resistance factors. Indeed, there were observations made by the Reefscapers program that suggest that shaded and deeper frames resist better to bleaching. And this study showed that they provide satisfying coral growth. So this first step was essential, as there will be little interest for restoration programs to just find good bleaching resistant factors, but that would yield poor overall coral growth. So the next steps would be to actually conduct dedicated studies to assess this potential bleaching resistance. And those studies will be really valuable for restoration programs, as they will enable them to target really the conditions according to their final aim. So either go for a really fast growth rate over the short term, but a potential higher susceptibility to bleaching, or compromise on the growth rate, but increasing the survival and the long-term efficiency. Before concluding, it's important to highlight some limits of this study. First, the environmental conditions at the study sites could not be measured due to lack of adapted scientific equipment. So to solve this, great care was exercised when choosing the study sites in order to really reduce to a minimum the variables that were not tested. The method of photoanalysis presents the drawback of reducing a 3D structure to a 2D object of study. So as some colonies can be hidden by others or by the frame bars, the exact numbers may not be completely reflecting the reality. However, the trends, patterns, and differences that are highlighted here are actually reflecting the reality, as the analysis was conducted in the exact same way and the setup was identical for all the frames. So it's the thing that is the most informative for this study, rather than completely exact figures. And finally, there is a really high variability of environmental conditions and also flora and fauna composition in the Maldives. So the guidelines that are presented here are useful for any restoration programs as paths that can be exploited and yield good results. However, specific pilot studies following the procedures described here should be carried out for local scale adaptation of those guidelines. In conclusion of this project, it really represents valuable information for the specific program of Reefscapers, as it assesses its efficiency under several conditions, which had never been done before. The guidelines are that the shallow sun and shade conditions present the fastest growth rates, but also that the deep condition can be exploited. So actually, the selection of the sites on where to put the frames really depends on the final objective. The shade condition really presents promising results, as it doesn't seem to impair growth, and it's also, from literature, it seems to be the first time that this condition was so specifically tested, so it's really interesting. And then further studies should be carried out to establish if sunlight exposure and depth present some measure of resistance to bleaching. So shade and increasing depth seems to be a good candidate for this. Those studies would be highly needed and valuable, as in the context of climate change and bleaching events, finding bleaching resistance factors is the most urgent issue for the long-term conservation of coral reef. I would like to thank the Reefscapers company that hosted this thesis and allowed access to their data, as well as my supervisors that helped for this. Thanks also to the IMBRC Master Program for the opportunities over the last 2 years, and thank you very much for your attention.